Good morning, students. This is 8085 instruction sets. So before that, data transfer instructions, arithmetic instructions, then branching instructions are completed. Now this one is fourth category of 8085 instruction set. The name is logical instructions. So what is logical instructions? These logical instructions include logical operations such as AND, OR, XOR, compare, rotate, and complement, etc. So these are all the some logical operation we have to done using these logical instructions. So all these logical operations AND, OR, XOR, compare, rotate, and complement are performed with respect to the content of accumulator, and result is again stored in accumulator. What is all the logical operations with respect to content of accumulator, and result is again stored in accumulator. So this is the purpose of the logical operations. The next one, all the logical instructions affected all the flags, namely sign flag, zero flag, carry flag, auxiliary carry, and parity flag. Before that, in data transfer instruction, branching instruction is also affected all the flags. The only instruction data transfer is does not affect any flags. Okay. Now we shall explain one by one for logical instructions. First one is CMP, that is compare register. Compare register with accumulator. Compare register or memory with accumulators. There are two operand, one is register or memory. You can take register directly or the memory content. The meaning is the content of specified register is compared with accumulator. The comparing, because comparing means the operand data and the accumulator, the content of accumulator. For comparing, the main purpose of comparing is done with subtracting register from accumulator. What is subtracting register from accumulator? But both contents are not changed. So this is we have to done the comparison. Here the flags alone are affected. I already told you all the flags are affected in logical instructions. Okay, so this is comparison. Okay, next, compare immediate with accumulator. Compare immediate with accumulator, CPI. Before compare register or memory, here compare immediate data, that is a content of accumulator and operand data. Content of accumulator and operand data. Here also the comparison is done by subtracting data from accumulator, but accumulator and the operand data, but the both contents are not changed. But flags, here the flags are affected. So how the flags are affected? There are three conditions are there. If a is less than data, and that time the carry flag is set, that is 1. If a is equal to data, both the accumulator and the data operand data is equal, the zero flag is set, that is z equal to 1, otherwise 0. Another one condition, a is greater than data, carry and the time carry and zero flags are reset. So reset is 0. Both the carry flag and zero flags are reset. So this is the condition. This is the three condition for uh, comparing both accumulator, content of accumulator, and operand data. Okay. The next, Third one, logical and, that is ANA. ANA register or memory. ANA register or memory. The full meaning of this instruction is logical and register. Logical and register or memory with accumulator. It is logical and register with accumulator, or logical and register, logical and memory with accumulator. Okay, so you already know that and operation. What is and operation? So and operation means both inputs are high, the output is high. Otherwise all other alternate inputs are 0 0 0 1 1 0. These are all, the output becomes low. So this is the and operation. Here in logical and, the content of specified register is logically and with content of accumulator. Okay, the content of specified register is logically and with the content of accumulator, and the result is stored in accumulator. So this is the meaning. So here we have to done and operation. Simply we call it as and operation. Okay, here the sign flag, zero flag, Faraday flag are affected. The result of flags are affected, but in carry is reset, accumulator is set. So there are some examples. ANA for B, that is and accumulator with register and accumulator with memory. So there are two examples. And the next one, ANI. ANI data. ANI data and immediate with accumulator. Logical and immediate with accumulator. Here the meaning is the specified data is and with accumulator. Before the specified register is and with accumulator, here the specified data is and with accumulator. The result are stored in accumulator. So here the same concept, ANI, that is accumulator, content of accumulator and data are and. Okay, here also the sign flag, zero flag, Faraday flags are modified. Similarly, the carry and accumulator is, carry is reset and accumulator is set. Okay, next, XRA. Exclusive or register or memory with accumulator. Exclusive or register or memory with accumulator. The only difference in R or XR is both inputs are same. Both inputs are same. The output is low. Alternative inputs becomes high. But in OR gate, only one inputs becomes high. The output is high. So this is the difference of exclusive OR and OR gate. So here the content of specified register is logically XORed with the content of accumulator. So this is the meaning for XOR gate. So 0 0 means it is 0, 0 1 means it is 1. That is alternative inputs. 1 0 means 1, 1 1 means 0. So 0 0 is 0, 1 1 is 0. Alternative becomes the output is I. So this is exclusive OR. Okay, next, exclusive OR immediate with accumulator, that is XRI data, 8-bit data. Here the specified data is, that is specified 8-bit data is XORed with accumulator. XORed with accumulator. This is directly the data is presented in our instruction. Before that, the indirect instruction, that is the data is presented in your register or memory. So that is the difference of XRE and XRI data. Okay, next, ORA. So ORA means logical or register or memory with accumulator. So logical OR means 0 0 is 0, 0 1 is 1, 1 0 is 1, 1 1 is 1. So this is the logical OR gate. Here also the content of specified register is logically ORed with the content of accumulator, and the result is stored in accumulator. Here the sign flags are also affected. The carry and auxiliary carries are reset. Before the carry is set, then auxiliary carry is reset for A and A, that is AND gate. Here the OR gate is both carry and auxiliary carries are reset. So that is only difference for the logical operations, the logical instructions for ANA and ORA. The next ORI data. Logical or immediate with the accumulator. Logical or immediate with the accumulator, that is the specified data is ORed with accumulator and the results are stored in accumulator. The meanings are same, but the indirect data before ORA register is indirect data. This is direct data for ORed with accumulator, content of accumulator. Okay, so here the carry and auxiliary carries are reset. The next one of the important instructions in logical instructions in 8085, that is RLC. So RLC is meaning of rotate accumulator left. Rotate accumulator left. Each bit of accumulator is rotated left by one position. Each bit of accumulator is rotated left by one position. That is bit 7. That is bit D7 is most significant bit MSB. Most significant bit MSB D7 is placed in the position of D0 as well as in the carry flag. Okay, so this is for rotate accumulator left by one position for each bit. For each bit, suppose we take one 8-bit data, for example 15, that is 8-bit data. So 1 is represented as in binary form 0001 and 5 is represented as 0101. So these are all the 8 bits. For 8 bits is presented as D0 to D7. For the most significant bit M7 is placed in D0. Similarly D6 is placed in. Likewise you can left all the bits for one for all the bits for rotated. That is the use of RLC. Okay, next RRC. Before in RLC, auxiliary carry, sign 0 parity auxiliary carries are not affected, only the carry flags are modified. So that is the difference of AORA and AND ANA. The logical instructions are affected all the flags, but here only the carry flags are affected and does not affect sign 0 parity in auxiliary carries. Okay, next rotate accumulator right. Before RLC, rotate accumulator with left. Here rotate accumulator right. Each bit, that is RR, each bit of accumulator is rotated right by one position. Rotate right by one position, that is starting from LSB, that is D0 to, that is D0 is placed in MSB D7 as well as in carry flag. What is the LSB, least significant bit D0 is placed in the position of D7 as well as in carry flag. Before that D7 is placed in the position of D0 as well as in carry flag. This is alternate for right operation. Okay, here also auxiliary carries are not affected, that is sign 0 parity auxiliary carries are not affected, only carry flags are affected. Okay, next one, rotate accumulator left throw carry. Rotate accumulator left throw carry, RAL, that is rotate all left. The other meaning is rotate all left. Each bit accumulator is rotated left by one position. Each bit of accumulator is rotated by one position. Before that in RLC, RRC only bit for rotated as well as in the carry flag. But here in rotate all left, all the 8 bits are rotated through carry flag also. So this is rotate all left. Here carry flag is modified according to bit D7. All other flags are that is sign 0 parity auxiliary carries are not affected, that is rotate all left. Similarly for rotate all right, so here each bit of accumulator is rotated by one position through carry flag. Each bit of accumulator is rotate right by one position through carry flag. Okay, well, that is LSB D0 is placed in carry flag and CY flag is placed in most significant bit. Okay, well, so this is rotate all right. Okay, next complement accumulator, that is CMA. CMA is complement accumulator. The content of accumulator are complemented. No flags are affected. Here CMA is no flags are affected. What is the meaning of CMA? That is content of accumulator. For example, the content of accumulator is 28 one 8 bit data. 28 is represented as in binary form 0010, 8 for 1000. So this is the 8 bit. These 8 bits represented as that the for applying CMA instruction, it's directly applied to complement. That is 0 is changed as 1, 1 is changed as 0. That means each bits are complemented for the content of accumulator. The next complement carry. The carry flags is complemented. Only the carry flags are complemented. No other flags are affected. Only the carry flags are complemented. So this is the meaning of CMC. The next last one, set carry STC. The carry flag bit is set to 1. The only carry flag that is set to 1. No other flags are affected. So this will complete logical instructions. Okay. Any doubt? Please contact me. Okay, thank you.